Okay, I will start with this question 1567. Let me just change the question number. Property is 1567. Okay, okay, let's go. Maximum length of a sub-array with positive product. Sure. Given an array of integers nums, find the maximum length of a subarray where product of all its elements is positive. If a subarray is a consecutive sequence of zero or more values taken out of that array, return the maximum. Wait, it says zero or more values, consecutive sequence of zero or more values, return the maximum length of the subarray with positive product. Okay, so the simple idea that I'm thinking about, let's go through the examples as well. We have 4, so the length would be 4. We have -2, -3, so again the length would be 4. And then the same goes here where the length would be, why not 4? Because, oh, so we worry about 0 explicitly. In that case, length is 3, that's why. Okay, sure. So here is what I am thinking. We are given an array A1, A2, A3, all the way up till an. Number one, if there's a zero anywhere in between, then we just split it into multiple arrays simply because zero will never be part. Any negative number can be a part. Let's say this was -4 somewhere here and this was -5. Then we can take both of them together and it would still be one positive array. So what I'm thinking is, number one, let's do we even worry about splitting about zero? What's the okay? My mind is initially going towards the greatest sum question that we all must have seen somewhere or the other. We're given an array. Let me go the volume real quick. Hmm, Is this understood? Okay, I'll make it public. So sure. Now let's and the volume for this. Hmm. Maybe I will change that a little too, because this would be extremely long. Okay, I hope everyone hears me loud and clear, and the music is also not too loud. Sure, let's get back to this. The largest consecutive sum problem. For example, here this would be the largest sum, but if this was a 6, then the entire array would become largest sum. There were two ways to do it, the global and the local maxima, maintaining that one, but the actual way on, not the actual way, but the kind of theoretical way of doing it is you keep a prefix and the suffix array. Basically, if we're talking about this point, then from this point, what's the largest array possible, including that element to the right, and what's the largest sum possible, including that element to the left? And then, or let's just say excluding that element, it doesn't matter. Uh, and in that case, what you do is simply just take the sum of these two for each elements, and it gives you your largest possible answer. Yeah. See, the reason I'm thinking about something like this is mainly because whether to include a negative number or not is the only question. Zeros will never include for sure, that we know. The only question then becomes is, let's say there's a negative number, then let's say we start over at even, and there's a negative number over here, let's say -x. Then is there a negative y to compensate for it later down the road? If there is, then we simply just continue this way. If there isn't, again, I'm just for now assuming there are no zeros, because zeros is basically just treating the question as several different inputs and then just finding the largest possible answer for each of them. It will break our initial question. Sure. Mm, Okay, let's see. we have -1, -1, -2, -7, and then 4. So we have using a2 -x minus y a4. Let's say I actually did the things. If there was a 0 here, then I just split about that array there. There might be another array here. There might be another array here. It does not matter. Currently, we'll just deal with this one. If we can calculate the answer for this one, then we can just calculate the answer for each one of them. The constraints are 10 to the power 5, which means linear time. So this would work because again, we are splitting the array. Now, how do I actually do this? Let's talk about this. Mm, So the only problem is negative numbers for us. For each individual negative number, we need to worry about, or rather, even negative numbers like that aren't our problems. The See, if there are negative numbers in between, for example. So let me correct this. Let's say we had -x, -y, a1, a2, -1, -2, -3, a4, a5. Actually, it'll change -3 and then -6. So all we initially worry about, like basically, let's say this would always be part of the answer. Only the initial negative numbers, if they come in pair, then we'll simply include them in everything before them, which was a positive number. And if they do not come in pair, then we worry about, hey, do we want to include this one or do we want to include this one? Which one has more more numbers after it or before it, which would kind of give us the maximum numbers. So again, how do I do that? Let's see. But, let's say we had a few numbers here, and we had -6, and then -7, and then we just had one number here, an. So that's the thing. I'm kind of wondering why would I start? Where do I even start? Do I start in the middle and then expand both left and right? Do I start at the top and then if we encounter a final negative number, or do I just count the number of negative numbers if they are even? Oh, I think that's the fastest way to do this. We just count the number of negative numbers in this particular array. Let's say it was even, then the entire array becomes our answer. If it was odd, then we see the first or last occurrence, and that tells us which one to pick. If the first occurrence, basically, I think maximum of, I think, first comma n minus last. That gives us which number to include, and then that would be like, that would give us our array. I'll tell you exactly what it is. So, should I start coding or should I? Okay, I'll figure this out. Yeah, I'll describe exactly what I mean. For example, in this particular case, let's say we have, again, assuming there are no zeros. That's like the first assumption. That's the only assumption. Because zeros case we can handle separately, and I'll show you why. So the first thing is, okay, we just count the number of negative numbers. That's very easy to do. So we have, let's say, odd negative numbers, because again, even is just include the entire array. The product would be positive. So if it is odd, then we see where the first negative number is. Let's say we had some numbers a1, ai, and then we had -x, and then we had some numbers in between, and then we had okay, my hand is going. Oh no, it is not. A aj minus y, and then we had some more numbers up till an. So the thing is, we can either include minus x or we can include minus y. We can include everything in between, but we can either include minus x and then keep the array till ej, that excludes one negative number which would make our product positive, or we include everything after, so this becomes ai plus 2. So we include from from ai plus 2 all the way up till the end. Now to figure out which one, we just find this index. Let's say this is ai plus 1 and this is minus y is a j plus 1. There are I plus 1 numbers before this, or sorry, I numbers before this, and there are n minus j plus 1 numbers after this. We include whichever has the highest. So this has I, so basically maximum of I comma n minus j plus 1. That is what we include along with that number, either minus x or minus y, and then all the numbers in between. So that would be j minus I plus 2. And that would give us our answer for this particular subarray. Now, if there was a 0, we'll just do the same thing for all subarrays. I hope this made sense. I will continue. I code everything in VS Code. So this is 1567. Let's see, 1567. So to get the maximum length, firstly, we split the arrays about 0. So if there's any 0, we just split the array about it. So let's say new nums is just an empty array for, should we do, yeah, sure. So an empty array with an array. Uh, this is basically what I mean. So we just append to the last array every single time. For num in nums, if num is 0, so 0 is the only special case, and in this case we just add a new nums. New nums start append. The string empty is uh, new nums minus 1 double append. No, now we have split our nums. Now let's just do the calculation that's on the whiteboard. So we have get max. I'll just break it here. Get max. Sorry, mouse. And list and then we just assuming that this works correct. We basically just do a return max new nums. No, but then it would do that. So we just calculate it for all. So answer is -1 for a error in new nums. Answer is equals to max answer comma let's put max len error and then simply return answer. Now let's implement this function. So now we just have this much. This is our array. So like I said, we find the first index of a negative number. So first neg is equals to 0 and last neg is equals to len nums minus 1 while I sure I is equals to 0 minus less than actually yeah. And then no. Should I even do this? Okay, let's calculate them separately. I'm trying to get ahead of myself, which is stupid. Nums and nums I equals is less than 0. So if I want when it is less than 0, then simply it is not less than 0. Let's change that. Once if there were no negative numbers found, then simply return len nums because again that is there are no negative numbers, so the product would always be positive. Otherwise, first neg is equals to I. Now I is equals to len num minus 1 while I is greater than minus 1 and nums I is greater than 0. I plus equals to sorry, minus equals to 1. Now we can be certain that there was a negative number because again first neg exists. Actually, let's call it j. So this becomes j, j, j. Mm, regards to j. So we have, let me fix this correctly. This was ai minus 1. So this was actually ai and then this was ai plus 1. Similarly, this was aj minus 1. This was minus y, which was actually aj, and then we have aj plus 1. That kind of fixes our calculation, so we can just do that directly. So it's either include all these numbers plus 1, which is basically I, or include all these numbers, which is n minus j, if I'm not wrong. So if we had 1, 2, minus 3, 4, 5, so if we wanted to include all these. Okay, what happens if there was just one negative number? That's something that I'm missing there because if there was one, then I'm still including minus x or minus 5, which I should not. Oh, and I'm not even adding the count, so I need to fix this. So now count is equals to 0. Mm, mm, but I once. No, I just this equals to minus 0. So 9% is 0. After precision comes into then we don't even need to worry about this one because this will be already 100. Now, if it is odd, so if it is just 1, mm, right? So we after getting the first neg, because we need the first neg, we do if is 1. So if we have just one negative number, then we get the first neg minus 1. So that's what it actually. So max first neg comma, len nums minus first name. So let me describe this one. So this scenario is when we have only one negative number. So we have one, two, minus three, four, five. Hmm. In this case, let's actually just keep it to four. So we have 0, 1, 2, 3. The index is 2. So the max would be, like we need to calculate basically return max of 2, comma, 4 len nums minus 2. Uh, this one actually, minus 2 minus 1. So minus first name minus 1. This handles maximum of this or this. Yeah. This is true for one negative number, and then after that we have three. So we need to calculate last neg as well. This makes it last neg while it is greater than zero. So also another greater less than zero will have last neg as j, and then we just do our calculation, which becomes will either include minus x or will include minus y for sure no. So all the numbers up till yeah, so basically, which like either this or this, we can include it only one of them. That's the idea. Everything in between will always be free. So, which one is more? That's the simple question. For example, if we had something like 4, 6, 7 minus minus 1, 2, 4 minus 2, 7. So we either include this array or we include this array and exclude everything after this. So if this is j, then we exclude everything after this n minus j plus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 minus 11, 11 minus 9 plus 1, sure. And then I is 2. So we have two numbers before it. Basically, we're trying to count how many numbers are there before and after the first one, last negative number. Yeah, I think that works. Or what we can do, because I could not say this before, the simpler way would be simply just return the maximum. So if we had even e2, we had a negative number minus x, then we had something in between with one negative number, so minus alpha, all the way up till a n a j minus 1. This is ai plus 1, let's say. Mm, and then all the way up till a n. So we can either take this much or we can take this much or this, sorry, this much, minus h and then this is minus 1. So we can take this much. So that's basically last index aj. This is a0, sure, aj, and this is an an minus 1. So we either take all the numbers before it, which is basically j, or all the numbers after this, which is n minus I plus 1. And we just return maximum of last neg of mm, what, len nums minus I, so first neg minus 1. And this should give us the correct answer. So let me test it out. Test cases. And just copy all the test cases from the LeetCode. Yes. No, if it's before, if no person to 0. Okay. It's 432. I thought that was the answer for 432. Let's try submitting this. Um, in case I get no question at time, and submit. Yes. Nice. Okay. Moving on to the next question. De Decremental string concatenation. Sure. Let me update the question number. Input 2746. Okay. And let me clear this out. You're given a zero indexed array words containing n strings. Let's define a join operator, join x comma y, between two strings x and y as concatenating within into x y. However, the last character of x is equal to the first character of y, then one of them is deleted. Sure. Then this becomes ABA, this becomes ABCD. You are to perform n minus 1 join operations. Word 0 starting from I equals to 1 up to for the ith operation, you can do one ordinary performing make string I join I minus 1 with words I, make string I join words I with I minus 1. Sure. Your task is to minimize the length of string and return. Okay. Okay. So sure. And then we have strings. I might convert. No, that one. And then we have 1,000. Okay. Let's see. Oh, I lost. Yes. I might even like okay. I think I hope everyone can hear. Yeah, I think this is working properly. Okay. Uh, let's start this question. Hmm. In this example, string 0 is A. Okay, so let's define a join operation. For example, n minus 1 join operations. String 0 as string from I equals to 1 up to I n minus 1. Sure. So we have to include all the strings and we have to minimize the length of the string. We're always eliminating at most one characters. So it doesn't matter if we decide to eliminate something or decide to not eliminate something right now for us to save it for later. Again, what I mean is, let's say we had str as AA, uh, and we had words may. The current word we are dealing with is, let's say, BCD. What I'm saying is, it would never make sense for us to do ACD, sorry, not do ACD, uh, to do B, C, D, A, B, and then in future, like just for future to be two B's, both of them will be eliminated. Oh, okay, it might be possible. Let me quickly confirm this. I think I chose the right answer. Right? We had A, B, and then we had B, C, D. If we decide to join them, then we would have A, C, D. If we decide not to join them, then we'll have join, not join, B, C, D, A, B. These are the only two possibilities. But let's say after this, words changed. So we had words I as, give me this, let's get this, I will shift this all. So we have A, B, and we have B, C, D. That was the first word. If we join it, then it becomes A, B, C, D. And if we don't join it, then it becomes A, B, C, D, A, B. The difference is of just one character. Let's say the next word that comes in is B, A. You just remove one word from one thing, and then the word after that is B, C. Okay. So when we did not join, okay, not B, A, let's say B, Z, or maybe B, A is nice to have. So when we did not join, again, we would just follow the greedy method. This would become B, A, B, C, D. And this would become B, A, B, C, D, A, B. No, actually, this time we would definitely break it. So what we will do is B, C, D, A, B, A. I don't think there's any point. Like basically, the greedy method would always result in the faster approach of the faster solution. And if this was C, B, then this would become C, B, A, B, C, D. And this would become C, B, C, D, A, B, A. We are allowed to choose any mixed string I, no, it's up to I minus 1. You are to perform join data. Okay, I think I'm complicating the question more than it needs to be. So then that makes it simple. Basically, let's just add them simply. I should I have that? You can have LeetCode. Oh, wait. It's auto pause. Let me just copy this over and we'll start this with the solution. So first things first, the idea is simple. We always have to add words. So our initial answer would simply be words 0. And then let's say for word in words once like enter, we add it to the answer. But again, the thing is, we do not add it entirely. If the characters are same, we can just add it wherever we want. So I'll just pick the greedy approach. If it breaks, then it breaks, and then we'll fix it later. So we just check if words, not word 0, is same as answer -1. Okay, now I think I realize where the problem might be. So where do we actually attach it? That is the real question. If even if it is not similar, so even if we take the greedy approach, there is a possibility that we have something like not A, B, and C, D. Then there are two ways to attach this. This can become either A, B, C, D, or this can become C, D, A, B. And depending on what the next words start or end with, would change the answer to this dramatically. So in one case, if we had, let's say, AX, then this would be shorter. This would become not AX, sorry, XA. Let's say. And this would become XABCD, but this would become XACDAB. So then that is the question, right? We have to know which one to add and what kind of answer is it expecting from us. Is the length? Okay. Right. Mm, So here's what I am thinking. We just try both, but in a smarter way. Mm, Words dot length does not matter because we only care about the first or the last letter. Mm, What else? I'm a little confused. Give me 1 second. Sure. I will keep this up. And this also makes me see what is visible. Typing too much on the this should be visible, but it's not. We have A, B, C, D, and X A. This could either make X A B C D, or this could make X A C D A B. Yeah. Since we have just 1,000 words, if we choose every single outcome, then it would become 2 to the power 1,000. But if we do it smartly, then I think we can do it in square. So all that matters is the first and last, right? For each word, what is a new first and last? If you have encountered that particular first and last before, so basically the key to a storing algorithm or whatever solution DP kind of, our DP key wouldn't be the entire word, it would just be the first and last character. If we have encountered this particular character before, then we just move on. When adding that, okay, the only thing that's kind of going through my mind is, can we do it faster if we do it from the end? So for an-1 and for an-2, oh sorry, for words n-1 and words n-2, can we figure out, is there an ideal way to join them? Basically, if those two match, or if they don't match, then that's the problem at start as well. If they match, then we know what to do. If they don't match, then we don't know what to do. That's the major problem. Okay. What about not having a greedy approach? What about when we do not match? Again, I'm a little confused about this. Do we always match this? What happens if we do not match this? This becomes A, B, B, A, or this becomes B, A, B. Sorry, this becomes A, B, A, or B, B, A, B. So we will have to explore both options, right? That's basically, even if we have the ability to match them, we should explore all options, is kind of what I'm getting at. And again, we just care about the first and last characters. So these again stop mattering as soon as we join the words. So I'll start with recursive solution then. I'm not 100% confident on the solution yet. Maybe I'm going wrong. Let's see what happens. Sure, let's try it. Uh, if, if index is 0, then we have words. Or let's actually, so one thing that I like doing is just writing the function within this function. That kind of simplifies a lot of things. Index would be initially 0. Anything else? Once you already have. And then push is also important. And cur, we do not know what cur is going to be. So cur would be those two characters. And then we just try joining them. I'll see if the DP solution, like the brute force DP solution I'm thinking of, doesn't work. If it doesn't, then we'll see what to do about it. So if I have, if I was at this position with the if I was at this index with the already present cur, then just return the answer from the TP. Okay. So if cur comma index in DP, return DP cur comma index. Just let's from if it wasn't, then we calculate further. Okay. We also need to have if I'll write base condition with index equals words. Don't simply return 0 because no, we also need the line. Okay, so we have cur, which is the two characters, but cur len is different. Cur len is just uh, what is the length actually. So while solving it, we just care about the two characters, but the answer depends on the len, right? So we just return cur len here. Okay, sure. Now finally, we actually check the word. Word is equals to words index. And then we test for both. I'll simply just test for both. So left join is equals to record curve would change to, so I'm joining the word, sorry, I'm joining cur plus word. Let me write it out. Word plus cur. Let's say this is what I'm doing in left join. So my word, the cur would become word 0 plus cur minus 1. Always, doesn't matter if we, even if, what if we had a, then it wouldn't become that. Yeah, but if we had a, so if this was this, then again it joins them and it says that it removes one of, basically कर से वो last वाला हटा देता है or first वाला, whatever. So it would just become a in that case. Given this, I think it's better to just skip this question. Okay. Uh, if this is happening, then yeah, I need to join it properly. I'm trying to join it in one line, which is causing the problem. Mm, mm. If word minus 1 equals cur 0, left word is equals to word volume minus 1 plus cur 1, not sorry, plus cur if this else word plus cur. Sure. And we just do, and this also handles the A wala scenario. So we just do left word, comma. mm, So what would the new len be if it was same? Okay, so let's actually think. Left same is equals to word minus 1 equals per 0. That's actually the only condition we're worried about. So if left same, then left word becomes this. Otherwise, left word becomes that. Based on left same. Sure. So left word would become word volume minus 1 plus per if left same else oxygen is a square. So that would become excluding the last. I'm gonna say first or last characters. I'll skip this question for now. It's taking me a lot of time and it's not productive. I hate questions in this. Longest repeating character sequence 424. Sure, let's solve this. I did. Okay, you're given a string s and an integer k. You can choose any character of the string and change it to any other upper English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letters you can get after performing the other option. Above option. So if you have A, B, A, B, and then if you have A, A, B, A, B, B, A, this looks awfully like the question we just solved. You're not allowed to change in one. Okay, so what's the so that's the longest subsequence, right? So for each point, we just see what's the longest possible subsequence after this is, and for which character, and before this is, and for which character, and for each point, what happens if I change it? If I change this, so the thing is, this isn't really a subsequence; it's just a substring. Yeah, longest substring. Since this is just a substring, but we can change multiple. That's the problem. If we could just change one, then it would be simple. Since we can change multiple, this I think again makes it a DP question. Or maybe this is just some things about strings that I don't know about. I will skip this again. Really bad at strings and all the time realizing. Odd, even, linked list given the head of a singly linked list, group all the nodes with odd indices. Okay. And the first node consists is considered odd. Okay. Okay. Sure. Mm, so then we just move that much. So one. Sure. Let's do this one. 328. One. Is 328. Okay. Let's do this one. So for this, what I'm thinking is we have a linked list, and again, the numbers in there do not matter. It can be any number. The idea is that we need to create a linked list that does this. Say we have this, and like condenses all of the even ones together or the odd ones together and the even ones together. So then it would become basically this. It's better to name them 1, 2, 3, 4, 5. So this would become 1, 3, 5, 2, 4. I hope that makes sense. I think that's easy to do simply because what we'll do is, or what I'm thinking is, we will uh, see how many we need to skip is kind of my idea. So when we're at the first one, we skip one and we just interchange these. This becomes 3, this becomes 2. And now we have the first two together and we just move our head here or our cur here, so to speak. Now we need to skip 2. So for each I, we just skip I nodes, get the I plus 1th node, attach it here, which is not difficult to do, and just continue. This way we'll just pick out the node that we want, attach it to its correct position, and then move on. So just cur is cur dot next. Okay. Okay, this looks extremely straightforward, which is a good thing. You must solve the problem in of one extra space and space complexity and complexity. Sure, I can do that. So LeetCode 328. Let's see. Okay. We'll do exactly what I just described. Uh, we'll have our I as 1 because they want the first one to be odd. And okay, actually I as 1, yeah. And then we'll skip I nodes, add the I plus 1th node to the current node, rearrange them a little. So actually we'll just go to I minus 1. Okay, I'll tell you what I mean. So to actually do this arrangement, this attaching, reattaching, the thing about linked lists is it's all about what pointer you have right now. If you miss out on that pointer, then that's kind of where the problem arrives. So if we want to attach this to this, we need this point, like basically a pointer to this, but we also need a pointer to this because we need to reattach 2 to 4. Otherwise, it doesn't matter. You would never be able to reach 4 if you rearrange this here and then 4 is lost. So to do that, and you also need 2 because 2 goes to 4. Yeah, makes sense. To do this, I think the best way is to just move I forward. So from the current node, just move I forward rather than moving I plus 1 and then just deal from there. What I mean is, you move I forward, this becomes your kind of new head or new whatever. And from here, you do the dot next. You connect this. You keep a kind of variable pointing to this, and then you connect this, and then you connect this. Okay, yeah, makes sense. Okay, square is equals to head while Actually, when I do not know how much my loop will run, I just do while true, and then while solving the question, I eventually realize, okay, this is how much my loop will run. So we are at cur. Actually, let's do while cur here, mainly because if we don't like basically if our cur is out of bounds, then we simply do not get. The only problem with this one is when do we stop? When do we know that the rearrangement is done? I'll tell you what I mean. For the simplest example of three nodes, 1, 2, 3, what we want the final output to be 1, 3, 2, right? The thing is, if we do this, the first time we do this, we get 1, 3, 2. But if we had even a 4 here, then what's stopping us from doing this? So do we need the count of how many elements there are? I think we do. We need to know how many total nodes there are in our linked list, and that would tell us how many times we run this particular operation. So if we have 4 nodes, then we run it just once. If we have 5 nodes, then we run it because there's a 5 here, then we run it twice. If we have 6 nodes, then we run it still twice because then this will become 5, 6. If we have 7 nodes, then we run it thrice, which is basically n upon 2. 6 is 3. No, so n minus 1 upon 2. So let me actually remove this. Count elements is equals to 0. Cur is head. While cur count elements plus equals to 1. Is equals to import next. So now we have the count of all elements. Now we do for underscore in range count elements minus 1 divided by 2. This many times we run this operation. And do we also just use that? I think we can. This becomes our I. We start at 1 and then we run it for plus 1 times. Sure. Now let's just solve this. So we have, we also need to have a curve. We have curve. From curve we move I steps forward to store the even node, last even node. So I'll just call it last even as none. And then we do for underscore, let's do last even as curve for underscore in range I, because we move forward minus 1 times. So I think I should remove forward items. So the first one is skip 1 node, so we just do 1. Yeah, sure. Last even is equals to last even dot next. If not last even, then simply return head. So the thing is, if we ever encounter a point where we do not have any further next, like odd node, but I think that should already be handled. We would never be at that point because we are doing it X number of times. Yeah, that would already be handled. We don't need to worry about that. So we have for underscore in range I, last even dot next. This gives us the position of the last even node, and then we simply do the pointer manipulation. So we do odd node is equals to last even dot next. That's our odd node. And we do last even dot next is equals to odd node dot next. Again, we can always assume that this odd node exists because uh, they can always assume this odd node exists because that's the number of times we are running this loop. This loop kind of is here to make sure that we run it the correct number, or this count, make sure that we run it only for required number of times. So an odd node definitely exists after it. So we do not even need to check for it. Mm, Now we do. Now we have attached the event to it. Now we just do color dot next is equals to odd node, and then we do odd node dot next. Oh, sorry. We, we need to do that before. Odd node dot next is equals to color dot next, and then color is equals to dot next is equals to odd node. We inserted that, and then we simply do cur is equals to cur dot next. This loop runs number of odd number times. Sure. If you have two, then we still run it 0 times. If we have three, then 3 minus 1 is 2, which is 1. So we need to run 1 time. Okay, yeah, this works. And then we simply return it. Let's try this. I think this should work. Did it run in an infinite loop? Yep. Okay, let me test this out. I'll do a quick dry run to make sure that I haven't messed up anywhere. I'm pretty sure this thing is correct. Uh, let's actually just go and count LMs just to be sure, and then I will quickly create a new one. Ask Jupyter to do it. And new variable test new this solution for elements 1, 2, 3, 4, 5, 6. No, this is not what I wanted. So I'll just do it myself then. And this equals to list node 1, comma, list node 2, comma, list node 3, comma, list node 4, comma, list node 5. And we just do not print, so let us run it solution dot odd even list. Okay, it runs on an infinite loop even before entering this. What did I mess up here? Oh, because I'm doing curve. I'm so sorry. Good, what next? And let's run this, and it prints 5. And let's do the same here. What next? Let's run this. Yeah, it works. It's submitted. It works. Nice. Next question. I don't want a easy question. Sure. First dominoes. There are n dominoes in a line, and we place each domino vertically upright in the beginning. Let me change the question number. Piece, LeetCode, integrate. Okay. In the beginning, we simultaneously push some of the dominoes to either left or right. After each second domino is falling to the left, pushes the adjacent domino to the left. Similarly, sure, when a vertical domino has falling, it stays balanced due to the forces. For the purpose of we consider that falling domino expends no additional force to a falling uh, or already fallen domino. You are given a string dominoes I L, dominoes I R are pushed to the right. Dot has not been. Return a string representing the final state. The first domino drops where it has fallen, so push to the right if it has fallen to the right. And then the next one stays as is. Sure. Example 2. And the first one is given left, so that dot also becomes left, and this one is given right. Okay, okay, sure. Uh, so this the first thing that's kind of going through my mind is if you push this one here, then this one doesn't fall, but this falls. Uh, if you were given, so the problem is to worry about if push that was coming from the right. If all the pushes were to the left, then the first push would make all of them fall to the left, and then the only ones remaining standing would be those ones. Uh, Other than that, okay. So one thing we can say for sure is if the first pushes towards the right, or if the last pushes towards the left, then the ones before or after it would always remain standing. Okay. I know that's an obvious conclusion, but kind of helps to reduce the size of a question a lot. So, for example, this in this particular case, oh, they have given that. So both of them have actually fallen. They consider them to be fallen. They do not consider them to be staying up, even if they're just basically inclined at each other. Okay. So now what do we do for this case? One thing that we can do is we can just increase time one by one, update all of them. How long would it take for uh, the actual answer to come up? So one basic thing is what we do is we actually just stimulate it. So this was t equals to 0, then at t equals to 1, this would have fallen onto this one, but this wouldn't fall. No, actually this, you can assume that there's a L force here and then there's a R force here. At t equals to 2, this will fall here and then this will fall here and then at this. Sorry, and this is R and this is L. And then at t equals to 3, this remains the same. So one kind of brute force approach is just actually to stimulate it. We do it again and again and again. We do it for, let's say, 10 to the power 5 times, because that's the most number of times anything will happen, because that's the number of dominoes we have. There is no idea where one domino will flip and then we have to run it more than 10 to the power 5 times. And for 10 to the power, the reason I come up with 10 to the power 5, that's the kind of end goal, because if the first domino were to start falling, then the last domino, and there were 10 to the power 5 dominoes, because that's the limit we are given. The number of dominoes can be at most 10 to the power 5. And the last one would receive the push, the L, at t equals to 10 to the power 5. This would definitely solve our question. The only problem with this is it would run in n squared time, which is fine. I'm just looking for a better solution. So let's see. For each domino, where would it fall? That is kind of the ultimate question, right? Let's say we had a domino here and here. So now even I don't know where it would fall. So where is the first domino that's falling? Actually, let's just assume that all of these are standing still. No. So the one that were given the initial push would always fall in that direction. Even if there was a domino right next to it, which was given a push in the opposite direction, they would still create that triangle structure, but they wouldn't not fall. It's impossible for them to not fall. Which means ki we can simply assume if a domino is falling to L, or if it was initially given R, then the final output would definitely be R. That cannot be avoided. Now, what about ones which were not given anything? For example, this one. All we need to do is find what's the closest R or L to it is. That's it. That's basically it, right? And if the R is closer, then it would for it the answer would become R. For example, if the L was closer, then the answer for it would become L. But if both were same, I think for this, into three, no. Okay, let's just remove this one. So if both were same, for example, this one, then the answer would remain a dot. Yeah, that's extremely straightforward now. So now given this, all we do is we just need to know where the nearest R or L to it is, right? And one thing that we can do is, that's for calculation. Yeah, so if there was a L right here, then this R doesn't count, or basically this R cannot interact with it. There would be some collision happening in between, and for it, this R wouldn't do any effect. Similarly, if there was a R here, then for this domino, this L wouldn't mean anything. So all we do is we just keep a count. That's extremely straightforward. So the way we do this is for this, it's R. Let's say this wasn't an L. So for this, we just check the last index. If it was, actually, let me actually fix this. Hmm. So let's say this is R. So for this, the answer is -1 because currently we have no R. For this, the answer is 0 because it's R. For this, the answer is 1. No, basically last index +1. For this, let's say there was an L force here. So we see that there's an L force here. So the answer would again become -1. We do not deal with these. For this, there was no force on it. And the last one was -1. So this remains -1. Let's say this was R. So for this, again, the answer would be 0, and then 1, and then 2, and then 3. And then we can do the same for L. So for example, for this one, -1, -1, let's say this was the actual scenario. So then this one, it would become 0, 1, and then again -1 because we have R, and then again -1. So we know that this one would remain standing because for L and R, both the distance is same. Okay, let's solve this quickly. It's LeetCode 838 if I'm not wrong. LC 838. Let's do nearest R as an empty array. Let's do nearest L as an empty array. I'll actually initialize both of them with -1, and then I'll just remove that -1. But this is to make sure that, uh, yeah, this is to make sure that we do not kind of break that. Okay. Uh, Basically, I wanted to get ahead of any index errors or anything, but I think I cannot do that. So for initial push in dominoes, not in dominoes, not this. Uh, so if initial push is R, then we know that nearest r dot append 0. Simply nearest. Let's actually, yeah, let's do the nearest L separately. If initial push equals L, then simply nearest R dot append -1. It's, so now we know it's a dot. Hmm. Now nearest R. Now what do we append to this? We need to know if nearest R. So if we have anything in nearest R, then we simply do so I was doing this. Ah, so we can just simply check if nearest are -1. So at the last position, if it was -1, if it was, then nearest are dot append still -1 because we do not have any push. If it wasn't -1, I guess anything other than -1 is simply nearest r dot append nearest r -1 plus 1. Exact same thing we need to do for nearest L is equals to -1. Or initial push in reversed nominals if initial push equals X. Let me just copy and paste it. I know I shouldn't be copying and pasting things, but for now it's just easier. And then we append -1 greater than 0, and or else we just let it be. We just change all these to nearest L. So we go nearest L dot reverse, and finally nearest L dot plot. And we also do it for this. We remove the first occurrence, basically, or the first -1 that we added for easier writing of code. Let's say star 1 second. And then now we just run the loop and figure out the answer for each of them. So we need to write on a string for I in range length nominals. If so, how do we actually do this? If we have a -1 for nearest star, and if we have any non -1 number for nearest L, then okay, let's actually think about it. So if we have a -1 for nearest star, if nearest r is equals to nearest r I, L is equals to nearest L I. If r is -1 and L is -1, then it's not going to fall. So answer plus equals to dot. Actually, I will make it an array. So in Python, you cannot actually mutate strings. So in that case, what I do is I just make it an array, and then append a dot and then create a string at the end. Okay. Hmm. Now, what other possible condition we have? If R is -1 and L is not equals to -1. So anything other than -1, answer dot append, it will fall to the left. Same goes for R is anything other than -1 and L equals -1. Answer dot append R. Finally, L if R is same as L. In that case, answer dot append dot. So I think this is same as this. So what we can do is simply remove this and just R is same as L. If they are both -1, if they cannot both be 0, they can both be 1. Okay. L R is greater than L, meaning R is less than L. Actually, जो भी काम होगा. So if R is less than L, then answer dot append R, or L is less than R, answer dot append, simply return dot join answer. I'm just thinking. Okay. Let's try this out. First questions, please. We have rr dot l, and then we have ll dot rr dot ll rr ll dot dot. Yeah, it's correct. I'm just thinking if I can shorten this a little. If r is less than l, it would complicate the if conditions. It would definitely shorten it. Yeah, I think I've written very bad code for this one. I think I can improve on the code a lot. But I'll try to submit this once, make sure that everything is working, and then we can worry about the code. Okay, it works. Now, do I want to shorten the code? Do I want to move on? What's the time? It's 4:30. Okay. I will move on. I won't worry about shortening the code right now. I don't get these kind of questions. Partition, array, SOR, and this one subsequences, maximize OR. Sure, let's do this one. Given two positive integers num1 and num2, find the positive integer x such that x is the same number, x has the same number of set bits as int2, and the value of x XOR num1 is minimal. Okay, sure. Seems straightforward. Let me quickly edit this to 242. Okay, I think I'll play Minecraft after this session. And let's try to solve this. So I only care about the set bits in num2, because otherwise num2 isn't being used anywhere else. So let's say we were given num1, and then we were given a count. That's the number of bits we need to have set in x. Now, one thing that you might be thinking, tell me one thing. Okay, this is stupid. I don't think this question is correct. Okay, no, we have to do bitwise or not and. Okay, this is correct. So to maximize to minimize the bitwise XOR, what we want is to basically set the highest bits, and then if we have any remaining ones, then we set them at the end. What if they're more than that? Uh, then they are more than that. Okay, so here's what I'm thinking. I'll just write the numbers in binary because that's easier for everyone. So let's say our first number was something like this, and the count was, let's say, 4. So we just try, like, basically a number would become, so if you do not recall, XOR is basically, I think if you write truth table, something like this. I've forgotten how truth table. 1 0 1 0 A B. If A and B both are 1, then XOR is 0. In this case, it's 1. In this case, it's 1. Otherwise, it's 0. So it's basically if either of them is 1, then it's a 1. Otherwise, it's a 0. Okay. So for this particular case, we want to minimize the number, which means we want as many initial bits as possible to be ones. And then if we run out of them, then we run out of them. Doesn't matter. So then that would reduce a number to the kind of least significant bits every single time, which would make our answer minimal. If we have equal number of bits, then our answer is always 0, because then we would always just make like basically turn on only those bits which are on number. Finally, if we have more bits than the number of bits in num1, then we only add, and then we start adding bits from the end, basically. One, and then only change zeros. No, no, no. Yeah, only change zeros actually, because if we change this to a 0, so like try to turn this off, then we will have 2 extra bits to worry about. So we keep doing this, and then if we have more after that, then we'll have to do this. Yeah, I guess that makes sense. Yeah, I suppose that makes sense. Okay, okay. So first things first. Okay, let me actually solve this. I think I already did that. Copy this to go to the music has stopped again somehow. Oh, man, this sounds like it stops. Okay, 249. Let's see, 249. Yes, yes. Okay. So firstly, we count the number of set bits in num2. That's all we care about. So count becomes bin num2 dot count 1. Okay, we have the number of set bits in num2. Now what we do? Now we kind of start creating num1. We initially set all the set bits, and then so what I'm thinking is basically something like this, where you can, like, you don't have so uh, uh, where you don't have, instead of creating the entire number, we just calculate what's the answer going to be. So if we have, let's say this one had, or this one had 5, right? 5 set bits. So if we have 4 or 3 or 2 or 1, then we just start canceling out the initial bits, like that many initial set bits, and then we just create the number. Okay. If we have the equal number of bits, then we return simply 0. And if we have more, then the idea is that we will have to set all the bits. No, we will have to iterate through the least significant bits and then just start setting them one by one. Whenever we encounter a one, we just skip over it because we have already accounted for it. Okay, okay, yeah, that works. So here's what I'm thinking in actual code. Count one is equals to bin num one. Actually, I need the binary representation. So bin num is equals to bin num one. And maybe we can just remove the initial 0b. Then what we can do is count one is equals to bin one dot count once. If count one equals count, then simply return zero. That is our kind of base case. So do not care about that case. Now, if it is less than count, then we ignore the initial bits and then finally start from the first most significant bit, if that makes sense. So if in this case the count was, let's say, one, oh sorry, two, so then we ignore these two and then this would be our actual number. If it was three, then we ignore the first three, and then from here we can just calculate the binary of that number. So if it is less than count, then we start to iterate over this. So for I n, okay, so let's see n equal one, if c equals one, then count one, sorry, count minus equals to one. No, actually, let's do it this with a while loop. That's easier. C is equals to 0 while count, sorry, then 1 C equals 1. No, not equals 1 actually. While count minus equals to then 1 C equals 1 and this C plus equals 2. So now this gives us the as soon as count is 0. So to remove the last one. So now we can just do return in count. Sorry, bin one C to end comma. Good. So for base two. I'll actually start testing these out as well as I am going. That makes it easier. The first one it gave output as 0. 1 to 5. That is incorrect. Why did it do that? So in 3, let's take this example of 3 and 5. In 5, we have 2 bits set. In 3, we have, oh, so we need to not return. Okay, what do we need to return? Do we need to return the XOR or X? Return the integer X. Okay. Okay, we need to create the actual integer. Okay, sure. So my method is still correct, just the implementation is incorrect. Return num1 simply. the actual integer. So while count, also we just fill in x at those positions. Yeah, that makes it easier, honestly. So while C, while count, this changes to x. Actually, this stays the same, and we just do x plus equals to. So again, I'll do the same thing. I'll do there x not append, and then I say, and then let's say if it's a 0 or if it's a 1, we're just adding to it. And then c plus equals to 1, count minus equals to this. Sure. So whenever we run out of count, we still have x created, which means we can just do in dot join x. And then if we run, I'm so sorry. Nice. Okay, the first one is correct. We get 3. For the second one, we are getting string index out of range, which shouldn't technically be possible because since count 1 is less than count, it means the number of is less than sorry, count 1 is greater than count 1. 3 and yeah, it makes sense. The second example is 1 and 12, which means we have more numbers than that. 12 is what? 1010, 8 plus 4. So if you have 3, which is 1 1, 12 is not 1 0 8 plus 4. Yeah. Oh, 0 1 1 0 0. Sorry. This is 12, right? Then the answer would be 3. Oh, the number is 1. Yeah. So the least possible number we can create is 3 in that case. So now we know that count 1 is less than, so basically the number of set bits in 1 or the num is less than the number of set bits that we need. So we'll just have to set all the bits. There's nothing else because we'll just set all the bits. So it's basically return 1, sorry, in 1 star count. And if we run this, then we get 3 3. Not 100% sure. I don't know why I'm not confident about this part, maybe because we never tested it. So let's actually test it. I'll add a test case of my own where we'll have 15 because we have 4 bits there, and then we can just set 3. So 3 will be 7 at most. So the answer in this case should be 1. Basically 7 has 3 bits, so the number that we would create is 7. So the answer should be 7. We set all the first 3 bits, so it's 1 1 1 0, and then 15s or 14 is 1. Yeah, makes sense, and that's the minimal zone we can get. We cannot get any lower than that. And if we run this, then we get 7. Yeah, perfect. Okay. And then I'll start with this. Okay. Broke somewhere 25 and 72. Let's see what broke. 5 and then 72. We run this, we get 3. Let's try to see what the answer would be. So I'll just quickly actually check the binaries. I have to do it manually. Bin 25 and then bin 72. So again, in the next number, only the number of set bits is important. So this is what I will do. Oh, 72 is what? 64 plus 8. Okay, just 2. So we have 110. So the our answer should have been 24 and it gave 3 as the answer, which is unexpected. The reason why I'm saying answer should have been 24 is simply because we're just allowed to create a number with 2 set bits and minimize the XOR. So we'll just create 24. This is 24 because this is 25. Again, if we reset the last bit, then it's just 1 minus. Okay, so then this one, like this region is where it broke, but why? What I'm doing is, let's see what our x came out to be. And x, x equal to this, and then just try this. X was 1, 1. Oh, okay, that was stupid. Yeah, so x needs to have the same length as num2 in this case. So I think there's a way to do this. Dot pad, okay, dot join x dot pad. There was a way to pad a string. I forget what it is. Pad was in Python. Ah, I'll just, I forget. Right hand character. So basically I just pads on the left to right align and L just to left align. So I will just do dot L just now width return left just of length width. So then bin 1 and then we need to pad it with zeros. Okay, on this again, and we get 24. Okay. Let's see this. Some 67, 65, 85. Should not be happening. 65, 84, 1.5. Okay. Let's see. Again, I want to save binaries for both of them. Then 65. Also link then 84. But we have 1, 0, 0, 0, and 3. So the answer should have been 3 and not 7. Sorry, the answer should have been 2 and not 7. The answer should have been the number. So it's that 80, 65, right? So 67 and not 7. Okay. So why do I say the answer should have been 67? Because, and then this is the excess case. And what am I doing in the excess case? Yeah, I'm stupid. That's why. So in excess case, we do not just set all the bits. We start with the initial num and then at the ends we set the bits. Okay. And then if we have more, then we have to start adding bits at the start as well. Okay, so we have count and then we have that. So our x becomes list of num1, so bin1, and then for I in reverse range len bin1. In this particular case, we do if I, oh sorry, if xi is 1, then simply continue. Else if it is 0, then xi becomes 1, and we change count to -1. If count is 0, we break, and if count is still not 0, then we do x is equals to 1 star count 6. So the remaining we just have to add them to the start. We cannot not add them basically. And count will change to count minus equals to count minus equals to, sorry, I lost my train of thought. Count my this count is yeah, sure. So we just keep on adding them, and then if we still have count remaining, and then we finally return and dot join x on the and this, and we get 67, 24, 14, 3, 3. Okay, I'll solve this daily back. Finally, let's do one more. I'll play Minecraft. Accounts merge 721. 721. Okay. Given a list of accounts where each element account size is a list of strings, where first element is the name and the rest of the elements are emails representing the emails of the account. Now we would like to merge these accounts. Two accounts definitely belong to the same person if some common emails in both of them. Note, even if two accounts have the same name, they may belong to different people. Sure, a person can have any number of accounts initially, but all of their accounts definitely have the same name. Okay. The first element of each account is the name, and the rest of the elements are emails in sorted order. Okay, sure. So instead of having this, like we just compress all of it to a set, like the rest of them as a set, and then we just do unions in the set. Figure out. So I have John Smith, Johnny Bravo, John Smith. Okay, we have two John Smiths. John underscore. And then we have a Mary, so we'll have one Mary. Oh, we have Johnny Bravo separately. Okay. So, okay. Give me 1 minute to think about this a little. What is happening here is we kind of firstly filter out the names based, sorry, firstly filter out the list based on names. So we have all Johns together, and then we have a set of all of their emails. And what we just run that, we can have a hash, but it would be the exact same thing. So the reason, okay, what I thought was we can convert the emails to a hash. That way we would have one number to compare, but it's not much different. The length of an email isn't more than 30. So again, it's not really that big a deal. The core problem is actually comparing this set to every other set and then seeing. I'm just thinking if it would be faster to do something else here. If there's a better thing that we can do in general that would resolve this better. I don't genuinely think there is. And basically this kind of makes me believe that it is expecting a solution n squared, and plus Python set union and those libraries are pretty optimized. So I'm thinking just using them directly. Just thinking if there's a better way that I'm just missing completely. So if we have multiple emails and there's one number here and one number here that are common, that are actually like belong to the same. So we need to merge these two entirely, and then we can spread all of them out later. The thing is, to merge them, we need to check at least. So this becomes our primary list, let's say. So we need to check all these emails in this list. If they are present, sure. If they're not present, then sure. We just like this becomes another one of our lists. So the core problem is we won't be just comparing each array to one of the lists. We'll be comparing it to all of the lists and seeing whether any of them match. So I think that's the biggest problem here. How do we do this? Literally blanking. No idea how to do this. So we have one list of, let's say, 1, 2, 3, 4, 5. We have another list of 1, 6, 7, 8, 9. Another list of 1000, 1001. And then we have another list of 5, 6, 1. And then we have another list of 2000, 2001. And then we have another list of 1000. So by this point, we have already created 3. And for this last one, we'll have to check with all of them, basically unionize with all of them and see if there's any common element. Now, one thing that we can be sure of is as soon as we are on a list, all the above ones are unique. But that doesn't really help us at all. Because again, all the above ones have to be checked. Since it's emails, again, the whole thing is we cannot simplify emails. we can do groupings, I think. So for each of these elements, yeah, I think that's better. We do not have a lot of emails. I think that would be much better than doing this. So the number of accounts is longer, but each account can have only a limited number of emails that's given here. So each account can have at most 10 emails, which means we'll have at most 10,000 emails. If I'm not, sorry, 9 emails, honestly, 9 emails, 9,000 emails. This means that even if we create a list of just basically a dictionary of all emails and point it to one particular John or one particular group, then at the end we just filter out or basically take out all the emails with the same groups. So here's what I mean. Let's say we have this. Uh, sure. Sorry. Let's say we have this. We have wait, 1, 2, 3, 4, 5, and then we have 1,000, 1,001, and then we again get 1, 2. Okay, so one thing that changes is if we had 1 and 1,000, then this now links both of them to the original list that we'll have to deal with. There's just nothing we can do about that. And there's nowhere given key two accounts definitely belong to the same person if there is some email common. Note that even if have the same name, any number of accounts initially, but all definitely have the same name after merging the accounts return. Same person if there is some email in common. Oh, so they're just saying definitely belongs. They're not saying the negative key. If they do not have any emails in common, then they do not belong to the same person. And that kind of proves this point key. Even if these two do not have any emails in common, this new one brings commonality to all of them. So yeah, I still think the grouping method would be better here. What we will do is we'll go through each email. 1 belongs to the first group, 2 belongs to the first group, 3 belongs to the first group. Let me add 2,000 as well. 4 belongs to the first group, 5 belongs to the first group. Addition of these. Then 1,000 belongs to group number 2 because it's not already present. 1,000 and so 10,001 belongs to group number and 2. But then this one comes along and says 1. So it says 1. So since this is already part of group number 1, so then this should also be part of group number 1. But it says group number 2, so then we need to change all 2's to 1. What I'm thinking is, do we just keep a merge kind of a list of what groups belong together that we could not initially figure out, but later on we figured it out. What I'm saying is we have a separate kind of list with the same groups, and then in that we just put in 1, 2, and then 2,000 just comes down to group number 3, and then 2001 also comes down to group number 3. Finally, when we need to combine all of them. To do that, what we do is we check from this aspect. I'm a little confused. You also need to worry about that. Okay, I suppose what you can do is you can just say 2:1 here. Let's make this a dictionary as well. Add 2:1. So we'll just give preference to the lower numbered group always. There's no specific reason to do that other than that would always be consistent. So if there comes along another one of these, let's say 3,000 and then 3,001, then these are given. Let me just have 3,000 group number 4, but then if another one comes along as 2, 3,000, then 2 already belongs to group number 1, so 3000 needs to belong to group number 1, but it does not. So we just say, oh, group number 4 also belongs to group number 1. This way, now when we finally start to compress it, we do it using, like we keep this in mind as well. So we iterate over all of them. We say, okay, 1 belongs to group number 1, 2 belongs to group number 1, 1000 belongs to group number 2. We check it here, or group number 2 already belongs to group number 1. So we add it to group number 1, so on and so forth. Group number 1 can basically be just the index. No, it cannot be. But like we can keep again a dictionary, basically a keep value pair where I'll have the final email. So 1 and then all the emails. And then this just points to this John. Okay, let's try it out. I think this makes sense. So the first thing that we'll do is we'll just combine all of John's and have all of their emails. Next thing we'll do is for each of them we'll do all of this. So basically for each individual person we'll do all of this. And then finally we'll get the output. So first element account name, the rest emails in sorted order. The accounts themselves can be in any order, sure. Then that makes our job very easy. This is LeetCode 721. LC 721. Okay. And what is this? Not industry. Right. Okay. So the format that we're given is in. Firstly, we will have names as a dictionary. And let's make it a default type just to make our life easier. And we'll define this a list of accounts. We can do for name, comma, start emails and accounts. This collects all the emails in just emails, and then we can simply do, can we create it at the same time? No, let's not do that. Let's not make a relation complicated. So we will simply just do names, name, dot append set. I don't think even creating a set now is required for emails. Okay, I'm still not 100% confident on the code, but like how am I going to code it all basically? Def combine. This does the combination. So name, emails, and then finally return answer. Okay. I cannot do it. Okay. So now to do the combination, we follow the exact trick. We will add all the emails to a dictionary. So we'll have email dic, and we'll have a current group. What happens if the emails were, so one thing that I missed, which is pretty easy to solve. If this was the case, then it would try to firstly add 1001 into, no, sorry, not for this one. Let's say this one, if this was the case and we had 3000 before, 3000,2, then it would say, oh, this isn't found, then I should create a new group for it. But it should not, because we have to, so we'll just again sort it. Sorting helps everywhere. So I'll just actually store them sorted. sorted emails. So current group simply is 0, and then we start doing it for email list in emails. So for each list, for email in email list, mm, if email in, okay, but sorting doesn't help us either, honestly, simply because you can have one two. So let's say it was 0, 2. So 0 isn't anywhere, so it would try to create a new group for it. We'll have to do any. So if any number x origins, I should make this a 60. X and e, comma, variable becomes, oh sorry, x and email with email list. I don't know if any requires a list or any variable is fine. A generator function is fine, but I would add a list. So if any of them, maybe it wasn't not tested, honestly. Print any lambda x colon equals 5 comma range 100. Okay, and does not require list. But just to show it's range 5 and numbers and false. Yeah, that was the thing. It doesn't need to calculate if all of them are there. If I provide a list, then it will. So if any of them are in our already present email list, so if they occur multiple times, we'll have to check for each of them. Okay. So for email in email list, if email email and email tag. So now we know, okay, it is. So we just find the group. Yeah, first thing we do is find the group. Okay, I think we should just do it for all of them. So we find the group. So to find the group, we just do groups is equals to email pick dot actually group. We can just find the minimal group. Group is equals to name of email pick dot get email name of email in email list. So now we have the group. If group is name, group, then simply group plus equals to 1, and then for each email just set its value to current group. So for email email list, uh, email pick, email equals to current group. Okay. If it is not enough, then we have the group. So okay, let's actually do this thing. Mm, Instead of INF, we'll provide the group plus 1, and then we will simply do if group is greater than curve group, then simply do curve group plus equals to 1, and then do this equals to curve group. So if we find it at if we find a group, then it simply sets it to curve group. If we do not find a group, then then it creates a new group. What happens then? So we still need all of their groups. Groups. What is equals to groups? Just call it group one. And then if there are multiple groups. Okay, so I think we can just do that here. And group one, group group not equals not equals to group, then this is the condition where same groups comes in. As far as the okay, dictionary, this one here, same groups, email, email equals to group. Okay, this works because again, if we have email in email dict, but it is not the same group, then just add all of those groups to the same group. So now we have created the dictionary we wanted. We have both the dictionaries, so now our job is to combine them and then return them with the name. Okay. So to combine them, we iterate through all of the emails. We check their groups. So combine, let's call it, let's say it's a list. Yeah, actually name isn't even important here, just emails out. And then for email, email comma email text dot values if email same groups if group in same groups, group is equals to same groups. So is it possible to, okay, so let's, instead of if, let's do y. Let me think about it as well. So the thing is, it's possible that it is nested. What I mean is, I still think this would resolve most of it, but not all of it. So uh, let's say we had something like this. All of them belong to the same group, but just in different. So we had one. So this would make 1:1, 0:. Let's say a group was 0. Oh, sorry, 1:0. We had 2, so that would make 2:1. And we had 3, this would make 3:2. And we had 2, 4. So again, we have a same group. That would mean, actually, let's do 2, 3. 4, 3, 4. Sure. So we have a same group. So in that case, we just or create all of them. So this just adds 4, 2, and it does nothing else. Okay. Uh, let's say we got basically I wanted to nesting of this, basically multiple groups that belong to the same group. Okay. Okay. Let's say we have 3, 2. That would mean that since we have 2, so it would do nothing. It would simply add 2:1. We simply get 1, 2. That would add 1:0. And we yeah, the lowest group always helps us because then this works while we have a group, and while we have this group in same groups, simply update it. So this would always reach the lowest group. Okay. And then let's do combine as a dictionary and combine group dot append media. So it means before of type list. And then we simply do referral sorted email list or email list and group listing combined with this. I think this should work. So now that we have everything we need, we just do for name from the emails list in name start values, and we also have answers as an empty list. What form of answer is it expecting? Oh, just spread it out. Okay, sure. Uh, for emails in combined emails list. Now we have emails, so answer, start append, name, comma, start, actually answer, start append, and empty list. And the first one is name, and then for email in emails, answers -1, dot append, in and then nothing else. I just do one more second. This should work. Let's see. Rest cases. Managed to unpack expected. Oh, from new comma emails and sorry. I'm not going to items. Non-unpackable, it will be for email comma group in email electron values. I did the same thing. Okay, for email comma group and items. And it gave an output. I'm not going to test that output manually. Ask it to just test it here. And this. Okay, that's correct. And I'll submit it. I don't think this should give me a TLE. It gives me a wrong answer. That says it did not sort it correctly is all. So the first one has Lily 3, Lily 3, Lily 4, Lily 17. I have Lily 17, Lily 3. I do not have Lily 4 and it did not sort it. So that's one thing wrong. I can just sort it later. I think that's fine. But where did Lily 0 go? It went with the other Lily, Lily 11. Okay, let's see why. So we have Lily 3, Lily 4, and Lily 17, right? So Lily 3, Lily 17. Why did my output not give Lily 4? Why did it ignore Lily 4 with this one? I think I'll have to debug it. I do not have any other way to properly figure out what's wrong. Just copy this and paste it. I'll solve this one. I spent a lot of time on basic sunk cost fallacy. Let's see the names. We have just one name, okay, and then we have a multiple stack. Okay, so we have one with 17.m.co4 and then 3.m.co. Then we have 5, 3, 23. So all of these belong together. We have 0, 8, 1, 14, 23. So this, the 14 comes in here as well. And we have 4, I think I've already seen 4 as a 20 also comes here, which makes 5 also come here. I think that's a 20 as well, maybe I did not. 11 to 1. I don't think I saw any of them. And then 0, 14, and this 2. So these all belong together. Okay. Let's go with this. Sure. So we have emails now. Again, the exact same list. We have same groups. We have group as 0, and then for email list and emails. So currently email list would become the first one. Okay. Then we have group as 0 and group as 1 because yeah. So just increase it by 1. Okay. And then we just add all of them to the same group. Okay, so in our email bit, we have all of them in the same group. So this should already, yeah, it skips that. And then these are just added to the same group. And it is okay. So now email tip just has all of them in the same group. Now none of these belong to the same group, which is 0, 8, and 1. Do we have 1 here, 20 here? Okay, sure. We'll just add all of them. Okay, so now these three belong to group 2. Then we have 14 and 23. Maybe we have already seen, yeah, 3, 1. So we have already seen one of them. So yeah, so we have 14 and 2. That's why we have all of them in group 2. Oh no, this shouldn't be group then. Yeah, this is where I think I'm wrong. This should be group. This shouldn't be group, it should be group. Let me try it out. The reason why it should be group is simply because if this was group, then it would append some of them to the newer group, which does not make any sense. Let's try on this. Yes, that was the problem. Okay. 0, 9, 2, 3, 4. It does not have 1. It does not have 2. It does not have 3. It does not have 5. Start this one. This. Names again, just one fine. So parent list is this. That should just add it. This. Email did not add anything. Okay, yeah, nice. Oh, now I did, and then the email list parent list is 1, 1. Those two. We have 9 and 8. Those two will be added to. We have 16, 15 to add it to 3. Then we have 19, 20 added to 4. Then we have 6 and 7. Already seen 6 or 7. So this will be added to 5. We have 11 and 10. Have you already seen 11 and 10? No, we have not. So assuming the sort is lexicograpically sorted. 6. Now we have 5. We have already seen 5. And then 6. We have 6 here. So we should have something in same group. Yeah, 5 and 1. 5 is the same group as 1. Okay. Now we have 13 and 14. So I think we have seen one of them for sure. I thought we saw 14, maybe it wasn't in this one. So 7. Then we have 9. We've definitely seen 9, and we have 10. We have seen 10. So 2 and 6 belong to the same group. Yep, 6 is 2. Nice. Okay, I missed one. We can just try to read 3 and 4. We have seen 4, we haven't seen 3, so it just adds 3 to 1. Yeah, it does. Then we have 2 and 3. Again, we haven't seen 2, if I'm not wrong. Just adds 2 to 1. Oh no, we had seen 2, and it was in 2 and 1, so 2 and 3. Okay. How many are there? Okay, and then actually go here. Okay, so we have another thing is 8, which is fine. I mean, if we, even if we have it as 8, and we have a relation where 8 is same as 1, then we have 4 the same as 3, we have 7 the same as 3, and 6 the same as 2, and the 7 there was no relation. Okay, and then we just do the combination. So while group in same groups, group is equals to same groups. So group is 1. No, it's not. Okay, group is 1. So just add it to the point symbol. So it's what's so combined. Combine was 1 of these two. And now the group is 2. Again, not it. So currently we have Lily 5 and Lily 4. I will confirm this here. 5 and 4 do belong to the same one. Okay. And then just get started. So we have in group 2 Lily 9. And let me actually confirm the answer as well, just to make sure we haven't already gone wrong. But 9 and 5 4 should be in different groups. So we have 9 here. The list is it all just one list? Am I tripping about? Let me confirm this. So, oh yeah, it's all just one list. So we have already gone horribly wrong. And we'll see why. Basically, this should have combined everything. It's combined 7 to 3, 6 to 2, 4 to 3, 5 to 2. There's no 2 to 1. That's kind of the main problem. That's why this is not happening. And which one would have given us 2 to 1? Okay, okay. I think I see it. I think updating it when this is the case is wrong. So what I'm doing is I'm also updating that element. And again, we have a relation already, so it doesn't matter. Okay, let's see where group 2 and group 3 should have coincided. It's 9 and 8, right? It's 2. Yeah, this is Lily 8 and Lily 9. We don't have Lily 8 on here, but Lily 7. We have Lily 7 somewhere else. Yeah, but Lily 6. Lily 6 with Lily 5. We have Lily 5 with no, yeah, we have Lily 5 with Lily 4. So it should have combined. Okay. Okay. Think I get it. 3 combines with 4, 3 combines with 6. Trying to always reduce the groups, but always reducing them isn't the best thing to do, is it? Because 8 will combine with 1 and 8 will also combine with 2. Oh, I'm pretty sure I'm overriding them. Okay, okay. I think I know where the problem is when I'm setting same group over here. If email and email dip and email dip email is not equals to group, then I'm just simply setting it to. So instead, what we'll do is group is equals to that particular one. Wait a minute. Same groups. That one. Email is already in email group. Okay. So my email groups in groups. What is it? Register. Same groups. Should fix it. So we have multiple groups. That's the problem. So we have one linking to 7 and one linking to 6, right? We wanna link both of them to the original group. The problem is if we have 6 already linking to 5, and then we also link 6 to 2, then that is a problem for us. Actually, was if it in string groups is already present, then same groups that's email is a construct group. Do it. It's still split it by into the string. Okay, this is way too complicated. Sorry, I will skip this. It's taking a lot longer than expected. I will end the stream. Should I play some Minecraft? I'm gonna play some Minecraft. What am I doing? Oh, that's not live. Okay. I will play some Minecraft. And give me just 5 minutes. I'll be back. Sadly, I ended on a unsolved question, but I'll stream tomorrow. I think Minecraft if I feel like it. Maybe something else. So I think we should stop streaming from here. I don't know how to end stream. Maybe just end stream from OBS.